July 14th, 1944. A field somewhere south of Saint-Lô. The morning mist still clung to the hedgerows like smoke from yesterday's artillery barrage. Lieutenant General Omar Bradley stood in mud that had once been a Norman pasture, watching something that shouldn't exist. A Sherman tank, hull number 237, lurched forward with 4 steel tusks welded to its bow. The tusks looked crude, improvised, like something a desperate man might build in a garage with scrap metal and borrowed tools. The tank's engine roared, transmission screaming as the driver gave it full throttle. The steel prongs hit the hedgerow at 15 miles per hour. For a moment, nothing happened. Then the entire embankment exploded. Earth, roots, centuries-old vegetation, all of it erupted skyward as the Sherman punched through the wall that had stopped American armor for 6 weeks. The tank emerged on the other side, engine still running, guns still operational, crew still alive. Bradley watched that hedgerow disintegrate and understood what he was seeing. The tactical deadlock that had killed thousands of Americans since D-Day had just been broken by a sergeant with a welding torch and an idea nobody wanted to hear. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Bradley didn't know in that moment was that this unauthorized modification, born from frustration and built from German beach obstacles, would transform Operation Cobra from another costly assault into the breakout that would carry American armor across France. In 11 days, this improvised device would help shatter the German defensive line that had held since June. But the path to that moment began with a problem written in blood across every field in the Norman bocage. The journey to Bradley's demonstration started with terrain that Allied planners had catastrophically underestimated. The bocage country of western Normandy wasn't just difficult terrain, it was a landscape specifically designed by centuries of Norman agriculture to compartmentalize movement, to fragment armies into isolated units, to turn maneuver warfare into static slaughter. The hedgerows themselves were monstrous constructions, not simple rows of bushes like the name suggested, but earthen embankments averaging 4 feet high, sometimes reaching 15, topped with generations of tangled vegetation. The bases were solid earth and stone, accumulated from centuries of farmers clearing their fields and piling rocks along property lines. The vegetation on top grew thick and impenetrable, hawthorn and brambles woven together by root systems that had been establishing themselves since before the American Revolution. These weren't obstacles that could be driven around. They surrounded every field, creating a network of natural fortifications that stretched for 50 miles across the Cotentin Peninsula. Each field was small, rarely more than 300 feet across. The hedgerows between them formed walls that infantry couldn't see through and vehicles couldn't penetrate. From above, the bocage looked like a giant waffle, each square compartment a separate battlefield where visibility ended at the nearest hedge wall. The Germans understood what the Americans apparently hadn't. They'd studied this terrain for 4 years while fortifying the Atlantic Wall. They knew exactly how to use it. German infantry dug their fighting positions directly into the earthen embankments. Machine gun nests carved into the hedge bases were protected from overhead artillery fire by the thick root systems and earthwork. Mortar teams pre-sighted their weapons on the narrow lanes between fields. Panzerfaust anti-tank teams positioned themselves where they could hit American armor at close range with near certainty. Every field opening, every lane, every obvious route of advance had been catalogued and covered by interlocking fields of fire. The German defensive doctrine for the bocage was elegantly simple. Hold lightly in depth, make the Americans pay in blood. For every field, use the terrain to multiply the effectiveness of every defender. A single German squad, properly positioned in a hedgerow, could pin down an entire American platoon. 3 or 4 defenders with a machine gun could stop a company assault cold. The Americans learned this doctrine's effectiveness through casualty reports that became more horrifying with each passing day after D-Day. A rifle company would assault across a field. German defenders would let them advance into the open ground, wait until they were committed, then open fire from concealed positions in the surrounding hedgerows. American infantry would go to ground, calling for support, waiting for their own machine guns to suppress the German positions. But suppressing what you couldn't see proved nearly impossible. Artillery proved almost useless. The vegetation detonated shells in the treetops before they could hit German positions. The thick earthwork absorbed shrapnel. Defenders crouched in holes dug into the hedge bases, survived bombardments that should have obliterated them. The Americans tried using tanks for direct fire support, but the tanks themselves became the problem. A Sherman attempting to climb over a hedgerow would lurch upward as its tracks bit into the embankment. The tank's bow would rise, exposing its belly armor, the thinnest plate on the entire vehicle. German anti-tank gunners learned to wait for this moment. A Panzerfaust team hidden in the next hedgerow over would have a perfect shot at the Sherman's vulnerable underside. One hit would penetrate the thin belly armor, detonating inside the crew compartment or engine bay. The tank would brew up, burning crew alive or forcing them to bail out under machine gun fire. Even if the Sherman made it over the hedgerow, it was useless for several crucial seconds. The tank would balance on top of the embankment, tracks churning in air, main gun pointed skyward, unable to engage targets. German infantry would swarm the temporarily helpless vehicle. Tank commanders learned quickly that going over the hedgerows meant death. The alternative was to go around, using the lanes and gaps between fields. But every lane was a kill zone. German defenders covered the obvious routes with pre-positioned anti-tank weapons. A disabled Sherman in a narrow lane created a roadblock that stopped the entire column. The Americans found themselves funneled into predictable routes, where German gunners simply waited for targets to present themselves. Combat engineers tried solving the problem with demolitions. Teams would advance under covering fire, place charges against a hedgerow, blow a gap wide enough for vehicles. But the explosions announced their location to every German mortar team within range. The time required to place charges, take cover, detonate, and wait for debris to settle gave defenders opportunity to reposition, to bring more fire onto the breaching point. Each gap blown cost time measured in American casualties. By late June 1944, the American advance inland from the beaches had slowed to a crawl. Units were gaining ground measured in yards per day, not miles. Casualties were mounting at rates that made the beach landings look merciful by comparison. The First Army was bleeding itself white against terrain that seemed specifically designed to neutralize every American tactical advantage. Armor couldn't maneuver, artillery couldn't suppress, infantry couldn't advance without prohibitive losses. The bocage had become a tactical black hole, where American superiority in men and materiel simply didn't matter. General Bradley understood what the casualty reports meant. At current rates of advance and loss, the Normandy campaign would degenerate into the same kind of attritional nightmare that characterized the Western Front in 1918. The Americans would eventually win through sheer weight of numbers, but the cost would be staggering. The timeline would stretch from weeks into months. The strategic objective of breaking out from Normandy and racing across France would become impossible. The bocage had to be solved, and solved quickly, or Operation Overlord would fail its fundamental purpose despite tactical success on the beaches. The solution, when it came, emerged not from planning staffs or engineering battalions, but from soldiers on the line who understood that regulation solutions were getting them killed. Sergeant Curtis Coolin of the 102nd Cavalry Reconnaissance Squadron represented a particular type of American soldier. Born February 10, 1915, in Cranford, New Jersey, he was 29 years old by D-Day. Ancient by the standards of junior enlisted men, most of whom were barely 20, Cullen's age meant he'd survived the Depression. He understood improvisation not as innovation but as survival skill. When things broke and replacement parts didn't exist and official channels moved too slowly, you fixed things with whatever materials were available. You made do. You improvised. You solved the immediate problem using whatever tools and materials were at hand, and you worried about regulations later if you survived long enough for regulations to matter. The 102nd Cavalry Reconnaissance Squadron, part of the 2nd Armoured Division, had been in Normandy since mid-June. They'd spent weeks fighting through the bocage, losing vehicles to German anti-tank fire, watching tanks burn because they'd tried to climb hedgerows, seeing infantry pinned down because armour couldn't provide effective support. Every man in the squadron understood the problem intimately. The hedgerows were killing them, and nobody seemed to have a solution. The idea that would break the deadlock came during a conversation that nobody bothered to record officially. A group of soldiers, probably exhausted, definitely frustrated, discussing the bocage problem the way soldiers always discuss problems, with profane honesty and zero concern for military protocol. Someone, a man later identified only as Roberts, described as a Tennessee hillbilly by military historian Max Hastings, made a suggestion that his buddies initially dismissed as absurd. "Why don't we get some sawteeth and put them on the front of the tank and cut through these hedges?" The other men laughed. It sounded like something from a cartoon, not a serious tactical solution, but Culin didn't laugh. He understood what Roberts was suggesting. Not literal sawteeth, but the principle behind it. Heavy steel blades mounted on the bow of a tank, angled to bite into the hedgerow's earthwork, driven by 33 tons of armoured vehicle moving at speed. The idea wasn't just plausible, it was engineering obvious once someone said it out loud. The problem wasn't that hedgerows were indestructible. The problem was that Sherman tanks didn't have the right equipment to go through them efficiently. A tank trying to climb over a hedgerow was using the wrong approach. What if instead of climbing, the tank just cut straight through? Cullen started thinking about materials. Where could he find heavy steel suitable for making cutting blades? The answer was literally scattered across the beaches behind them. German engineers had fortified the Normandy coast with thousands of anti-tank obstacles. Czech hedgehogs, 3 steel I-beams welded together in a 3-dimensional cross pattern, designed to gut the bottom of landing craft or stop tanks at the waterline. The Allies had blown gaps through these obstacles on D-Day, leaving wreckage all along the beach. That wreckage represented hundreds of tons of hardened steel I-beams, already cut to manageable lengths by combat engineers, just sitting there waiting to be repurposed. Cullen requisitioned cutting torches and welding equipment. He scrounged a team of soldiers who knew how to work metal. They cut sections of I-beam from destroyed Czech hedgehogs, angled the ends into points, and started designing a mounting system. The challenge was attaching the blades to the tank in a way that would transfer the vehicle's forward momentum into cutting force without damaging the tank itself. After some trial and error, they settled on a design. 4 steel prongs, each about 3 feet long, angled forward and down like the tusks of a charging animal. The prongs were welded directly to the bow of the Sherman, specifically to the armoured transmission housing and the lower glacis plate. The welds had to be strong enough to handle the shock of hitting a hedgerow at speed without tearing free. The angle had to be precise enough to bite into the earthwork rather than deflecting upward. The spacing had to allow the prongs to grab enough of the hedgerow to hold the tank's bow down while it pushed through. Nobody asked for permission. Nobody filled out requisition forms. Nobody checked with higher headquarters to see if modifying government property without authorization violated regulations. Culin and his team just built the thing, working after duty hours in whatever space they could find, using materials that weren't officially theirs and tools they'd borrowed without asking. The first test happened without fanfare. Culin's modified Sherman approached a hedgerow, driver accelerating to attack speed. The prongs hit the earthwork and bit deep. The tank kept moving forward, engines screaming, tracks clawing for purchase. For a few seconds, nothing seemed to happen. Then the hedgerow started to come apart. The steel prongs were tearing through centuries of accumulated earth and root systems, excavating a gap wide enough for the tank to pass through. The Sherman burst through the other side, tracks still spinning, gun still operational, the crew inside unharmed and not exposed to enemy fire at any point during the breakthrough. The device worked. Not theoretically, not on paper, but in actual field conditions against actual Norman hedgerows. Culin had just solved the problem that had been killing Americans for 6 weeks. Word of the successful test spread through 2nd Armoured Division, faster than official communications channels could track. Tank crews started showing up wherever Culin was working, asking if he could modify their vehicles. Maintenance sections started fabricating their own versions of the device, working from Culin's basic design but incorporating their own modifications. Some crews wanted longer prongs for thicker hedgerows. Others wanted different mounting angles. Some Sherman variants needed slightly different attachment points to avoid interfering with the tank's mechanical components. The design evolved through rapid iteration, each modification tested in combat and refined based on what worked and what didn't. By early July, dozens of tanks in 2nd Armoured Division had been fitted with hedgerow cutting devices of various designs. The modifications remained unofficial. No technical orders existed authorizing the changes. No engineering evaluation had been conducted. From a regulatory standpoint, these tanks were non-standard vehicles that violated their type classification and probably invalidated their combat readiness certification. But from a tactical standpoint, they represented the first equipment breakthrough that gave American armor a fighting chance in the bocage. Other divisions started developing their own solutions. The 79th Infantry Division had a hedge cutter operational by July 5th. The 19th Corps demonstrated prongs that had initially been designed to create holes for explosive charges, but turned out to work for cutting hedgerows directly. The 5th Corps came up with devices they called brush cutters and green dozers. Multiple independent invention was happening across the American sector, different units solving the same problem in similar ways because the tactical necessity was so obvious and the conventional solutions so inadequate. But Coulin's design, or variations of it, remained the most widely adopted. The device had one crucial advantage over the alternatives. It used materials that were abundantly available. The beaches were littered with destroyed German obstacles. Every beach fortification the Allies had blown apart on D-Day represented more raw material for hedgerow cutters. Combat engineers could harvest steel from German defences, cut it to length, angle it, and weld it onto tanks without requiring any materials from the supply system. The entire modification could be accomplished using equipment and expertise available at the division level. No waiting for parts from rear echelon depots. No complex manufacturing requiring specialized facilities. Just cutting torches, welding equipment, and soldiers who understood metalwork. On July 14th, Coulin's invention received the attention it had been designed to avoid. General Bradley arrived at 2nd Armoured Division's position to observe a demonstration. The timing wasn't accidental. Bradley was finalizing plans for Operation Cobra, the massive offensive designed to break through German lines and allow American armor to exploit into open country. He needed solutions to the bocage problem, needed them immediately, and was willing to consider anything that worked, regardless of whether it appeared in any manual. Coulin's tank, fitted with the jury-rigged hedgerow cutter, performed for the commanding general the same way it had performed in actual combat. The Sherman approached the hedgerow at speed, prongs bit into the earthwork. The tank drove straight through without exposing its vulnerable underside, emerging on the far side ready to engage targets. Bradley watched that demonstration and understood exactly what he was seeing. This improvised device, built by a sergeant using scrap metal and unauthorized welding, had just solved the tactical problem that threatened to derail the entire Normandy campaign. Bradley's response was immediate and unequivocal. He ordered the device manufactured in quantity for as many tanks as possible before the launch of Operation Cobra. Not a field evaluation, not a study by engineering committees, not a cautious, limited trial. Full-scale production and deployment, as fast as division maintenance sections could accomplish the work. The order went out across 1st Army. Every available tank was to be fitted with hedgerow cutting devices based on Coulin's design. The logistical effort was extraordinary. Ordnance companies set up cutting and welding stations across the American rear area. Teams of soldiers worked around the clock under camouflage netting, protecting their work from German aerial observation. They harvested steel from beach obstacles, German roadblocks, destroyed vehicles, anything that provided suitable material. They cut, shaped, angled, and welded thousands of individual prongs. Every Sherman, every Stuart light tank, every M10 tank destroyer that could be reached before Cobra launched received some version of the modification. Colonel John Medaris of the Ordnance Department flew back to England to ensure tanks waiting to be shipped to France were modified before leaving British ports. Additional welding teams were flown into Normandy by air transport. The manufacturing effort became an army-wide priority, second only to ammunition supply in terms of urgency. By July 25th, the day Cobra launched, approximately 60% of 1st Army's tanks had been fitted with hedgerow cutting devices. The numbers tell part of the story. Around 500 Coulin-style cutters were manufactured by American units. British forces, calling the devices prongs instead of rhinos, eventually produced over 2,000 of their own versions for Sherman, Cromwell, and Churchill tanks. But 60% wasn't complete coverage. Some tanks went into Cobra without the modification. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this, either because they couldn't be reached in time or because maintenance sections lacked materials or welding capacity. The devices themselves varied widely in quality and design. Some were professional welds on properly angled steel. Others were crude field expedients that barely qualified as attached. Some tanks received full 4-prong assemblies. Others got simplified 2-prong versions or improvised ram bumpers that were better than nothing but far from optimal. The devices represented military expediency at its most pragmatic and most desperate. They worked well enough, often enough to make a tactical difference, and that was sufficient. Bradley forbade their use before Cobra for operational security reasons. He didn't want German intelligence to understand what the Americans were preparing. Every modified tank represented a capability the enemy didn't know about, a tactical surprise that would only work once. The Germans had to encounter these devices for the first time during the actual offensive, when they couldn't adjust their defensive plans to counter them. The secrecy worked. German units facing Cobra had no indication that American armor had solved the bocage problem. When Operation Cobra launched on July 25, 1944, the German defensive plan assumed American tanks would remain roadbound, that hedgerows would continue to channelize Allied armor into predictable kill zones, that the bocage would continue functioning as the Germans' most effective defensive ally. That assumption would prove catastrophically wrong. The massive aerial bombardment that preceded Cobra's ground assault was supposed to break German defensive positions through sheer destructive force. Over 1,500 aircraft dropped thousands of tons of high-explosive and fragmentation bombs on German lines south of Saint-Lô. The bombing was devastating but imperfect. Some bombs fell short, killing American soldiers waiting to advance. The bombing cratered the ground, but didn't eliminate German defenders dug into hedgerows. When American infantry and armor began their assault, they still faced organized resistance from survivors who'd weathered the bombardment in positions the bombs couldn't reach. This is where the hedgerow cutters changed everything. 1st and 2nd Armored Divisions led the breakthrough assault, their Shermans fitted with the prongs that Bradley had ordered manufactured in such desperate haste. The tanks didn't follow roads. They didn't wait for engineers to blow gaps. They didn't try climbing over hedgerows and exposing their belly armor. They just drove straight through the earthwork barriers that had been stopping American armor since D-Day. The tactical effect was immediate and profound. German defenders had prepared their positions assuming American armor would use predictable routes. They'd positioned anti-tank weapons to cover road junctions and field openings. They'd pre-sighted mortars on known approach lanes. Their entire defensive scheme depended on the bocage channelizing American movement into zones where German firepower could concentrate. The Rhino tanks invalidated all of that planning in the first hour of the assault. Shermans, equipped with Kulin's cutters, punched through hedgerows wherever they encountered them. Tank platoons that should have been stuck following narrow lanes instead created their own routes of advance. German defenders found themselves engaged from unexpected directions by armor that shouldn't have been able to reach their positions. The psychological impact on German troops was devastating. Imagine defending a hedgerow position that you know is effectively immune to frontal assault because the terrain protects you. Then imagine watching an American Sherman drive straight through the earthwork barrier you thought was impenetrable, emerging 30 feet from your position with its main gun traversing toward you. The Germans had prepared for many contingencies, but they hadn't prepared for American tanks that could ignore the terrain features that made defense possible. The breakthrough developed with shocking speed. On the first day of Cobra, progress was measured but steady. American units advanced further through the bocage in one day than they'd managed in the previous week. The hedgerow cutters weren't a miracle solution. They didn't eliminate German resistance or make combat easy. But they changed the fundamental tactical equation. American armor could now maneuver cross-country instead of being road-bound. Tank platoons could support infantry assaults by cutting through hedgerows to provide direct fire on German positions. Advances that previously required engineers and demolitions now only required a Sherman with steel prongs welded to its bow. By July 27th, the third day of Cobra, organized German resistance had begun to collapse. The breakthrough wasn't just tactical anymore, it was operational. American armored columns were penetrating deep into German rear areas, moving faster than German commanders could reposition their forces to counter. The bocage that had protected German defenders now trapped them. Units that relied on hedgerows for protection found themselves isolated and surrounded, as American armor bypassed their positions using routes the Germans hadn't thought possible. Major General J. Lawton Collins, commanding 7th Corps, drove his armored divisions through the gap with relentless aggression. The 2nd Armored Division advanced over 6 miles on July 27th alone, a distance that would have taken weeks in early July. 3rd Armored Division pushed through Marigny and continued south, knocking holes in hedgerows as they went, maintaining momentum that German counterattacks couldn't stop. The town of Coutances, a major German strongpoint, fell to 4th Armored Division on July 28th. The speed of the advance surprised even Bradley. American units were covering distances in days that pre-Cobra planning had allocated weeks to accomplish. The German defensive line wasn't just breaking, it was disintegrating. Units cut off by American armor's rapid advance either surrendered or attempted to retreat east, abandoning equipment and positions. By July 31st, American forces had reached Avranches, 35 miles south of their starting positions. The breakthrough that was supposed to take weeks had been accomplished in 6 days. The hedgerow cutters hadn't caused this breakthrough alone. The massive aerial bombardment, superior American numbers, excellent tactical leadership, and German exhaustion all contributed. But the Rhino tanks had solved the specific problem that allowed the breakthrough to develop into a breakout. Without them, American armor would still have been confined to roads and prepared routes. The advance would have been slower, more predictable, more costly in casualties. The Germans would have had time to establish successive defensive lines, time to bring up reserves, time to contain the penetration. The hedgerow cutters gave American commanders the ability to maintain offensive tempo at a rate German defenders couldn't match. General George Patton's Third Army, activated on August 1st, exploited through the gap Cobra had created and began the race across France that would carry American armor to the German border by September. The strategic situation in Western Europe had been transformed in 11 days, from stalemate in the bocage to mobile warfare across open country. The Sherman tanks, with their improvised steel tusks, had been the tool that made transformation possible. Curtis Culin never intended to become famous. He'd built the hedgerow cutter because the problem needed solving and nobody else was solving it. The device worked, other units adopted it, and suddenly Culin found himself the subject of press attention he neither wanted nor sought. Being an honest man, according to historian Max Hastings, Culin tried to give credit to Roberts, the Tennessee soldier whose offhand suggestion had sparked the idea. But Roberts had already been forgotten in the publicity surrounding the invention. Culin became what Hastings called a very American kind of national hero, the enlisted man who solved through practical ingenuity what engineers and planners had failed to address. He was awarded the Legion of Merit for his invention, a decoration typically reserved for officers and senior enlisted men who demonstrated exceptional service. The award citation praised his technical proficiency and innovation, though it carefully avoided mentioning that his modification had been completely unauthorized when he built the prototype. 4 months after his moment of fame, Cullin's war ended in the Hurtgen forest. A landmine cost him his leg and sent him home. He survived the injury, recovered, married, and returned to civilian life in New York City. He took a job as a liquor salesman for Schenley Industries, a position that had nothing to do with tanks or welding or military innovation. He rarely spoke about the war, and when he didn't dwell on his invention or its impact. To Culin, the hedgerow cutter had been an obvious solution to an immediate problem, nothing more. He died in Greenwich Village in 1963 at age 48, his obituary making no mention of Normandy or the device that had changed the course of the campaign there. His personal legacy survived mainly in the memories of men who'd served with him and in the handful of official documents that recorded his contribution. But the tactical legacy of his invention extended far beyond one man's recognition. The hedgerow cutter represented a particular approach to military problem-solving that remains relevant. When soldiers on the line identify tactical problems that official channels haven't addressed, what's the appropriate response? The regulation answer is to submit the problem through channels, wait for engineering evaluation, trust that proper authorities will develop appropriate solutions. This approach ensures safety, standardization, quality control. It also takes time, often more time than tactical necessity allows. The alternative is field expedient modification, soldiers using available materials and local expertise to solve immediate problems without waiting for authorization. This approach is fast, flexible, responsive to actual combat conditions. It also bypasses safety evaluation, creates non-standard equipment, and can result in solutions that work once but fail catastrophically when widely adopted. The tension between these approaches is inherent to military organizations. The hedgerow cutter succeeded because it landed on the right side of this tension. Coulin's design was simple enough to be safe, effective enough to be useful, and timing was such that official recognition came quickly enough to enable widespread adoption before the critical offensive. But consider how easily it could have failed. If Coulin's welds had been inadequate, the prongs might have torn free when they hit a hedgerow, possibly damaging the tank or injuring the crew. If the design had been fundamentally flawed, the first combat test might have resulted in a destroyed tank and dead crew, discrediting the entire concept. If Bradley had been less willing to embrace unauthorized innovation, or if the demonstration had been delayed by a week, Cobra might have launched without the modification. The device succeeded partly through sound engineering, partly through tactical necessity, and partly through luck. The operational impact of the hedgerow cutters remains debated by historians. Military historian Stephen Zaloga argues that the devices weren't as widely used as legend suggests, nor were they as effective as popular history claims. He points out that most German accounts of Cobra don't mention being surprised by American tanks cutting through hedgerows. German commanders attributed their defeat primarily to overwhelming American air power, superior numbers, and the cumulative exhaustion of 6 weeks of continuous combat. From the German perspective, the hedgerow cutters were just another piece of American equipment, not a war-winning innovation. But Max Hastings and Chester Wilmot, both respected historians of the Normandy campaign, credit the invention with restoring battlefield maneuverability to Allied forces. They argue that without the ability to move armor cross-country through the bocage, Operation Cobra would have devolved into the same attritional slog that characterized the previous 6 weeks. The hedgerow cutters didn't win the battle alone, but they enabled the American tactical approach that did win. The truth probably lies between these interpretations. The Rhino tanks solved a specific tactical problem that had been preventing American armor from operating effectively in the bocage. They didn't revolutionize warfare or render German defenses obsolete, but they removed a critical constraint that had been limiting American offensive operations. The breakthrough at Saint-Lô resulted from multiple factors working together: aerial bombardment, concentrated ground assault, German exhaustion, and tactical innovation, including, but not limited to, hedgerow cutters. Isolating any single factor as decisive oversimplifies a complex operation. What's undeniable is that American commanders believed the devices made a significant difference. Bradley ordered their manufacture and deployment as a priority equal to ammunition supply. Eisenhower, in a speech to the American Society of Mechanical Engineers years after the war, described the morale boost the invention provided to troops who'd been struggling against the bocage. The soldiers who used the devices in combat believed they improved survivability and effectiveness. That belief itself had tactical value, regardless of whether statistical analysis later confirmed their impact. The broader lesson extends beyond one battle or one device. Military organizations succeed when they can balance institutional process against individual initiative. The rigid hierarchy and standardization that enable large-scale operations must coexist with the flexibility that allows soldiers to solve immediate problems creatively. Organizations that lean too far towards standardization become inflexible, unable to adapt to unexpected circumstances. Organizations that lean too far toward improvisation become chaotic, unable to maintain the logistics and coordination that modern warfare requires. The American military in Normandy found an effective balance, at least temporarily. Official channels had failed to anticipate the bocage problem or provide adequate solutions, but when soldiers in the field developed their own fixes, the organization was flexible enough to recognize value, adopt the innovation, and scale it across the entire army in a matter of days. This happened not because regulations encouraged it, but because commanders like Bradley were willing to override regulations when tactical necessity demanded it. That willingness to embrace unauthorized innovation when it worked, and to provide official support once it proved effective, represented organizational adaptation at its most functional. The hedgerow cutter story also highlights how solutions often come from unexpected sources. Curtis Cullen wasn't an engineer. He hadn't designed tanks or studied mechanical systems formally. He was a cavalryman who'd survived the Depression and understood how to fix things with available materials. Roberts, whose suggestion sparked the idea, was described as a Tennessee hillbilly, certainly not someone military planners would have consulted about armored vehicle modification. Yet these two men, working outside official channels, solved a problem that had stumped professional engineers and military planners. This pattern repeats throughout military history. Soldiers closest to the problem often see solutions that distant experts miss. The infantryman understands terrain and enemy tactics in ways that staff officers studying maps cannot. The tank crew knows their vehicle's capabilities and limitations more intimately than the engineers who designed it. The maintenance sergeant understands what breaks and why it breaks better than the procurement officers who bought the equipment. Successful military organizations create pathways for this ground-level knowledge to influence doctrine and equipment development. Unsuccessful organizations ignore or suppress such input, insisting that solutions must flow down from authority rather than up from experience. The hedgerow cutter succeeded because the American military in Normandy, facing crisis, was willing to listen to sergeants with welding torches rather than waiting for engineers in distant offices to solve the problem through proper channels. That willingness to set aside peacetime procedures when combat demanded it represented organizational flexibility that contributed as much to victory as material superiority or tactical skill. Looking back from 8 decades later, the Cullen hedgerow cutter emerges as more than a piece of improvised equipment. It represents a moment when necessity drove innovation, when hierarchies flattened enough to let good ideas rise regardless of source, when institutional process moved fast enough to support rather than stifle creativity. The device itself was simple, crude even, just steel prongs welded to a tank's bow. But what it represented, soldiers solving problems, commanders supporting solutions, organizations adapting faster than enemies could counter, that remains the difference between militaries that win and militaries that lose. Curtis Cullen built something that broke through more than hedgerows. He demonstrated that the space between regulation and innovation, between official process and field expedient, is where adaptation happens. Military organizations that can occupy that space effectively, that can maintain standards while encouraging initiative, that can scale good ideas rapidly while discarding bad ones quickly, those organizations succeed in the chaos and confusion of actual combat. The ones that cannot, the ones that insist proper channels must be followed regardless of tactical necessity, they write regulations that dead soldiers followed to the letter. The Sherman tanks with their improvised steel tusks punched through the Norman bocage in days, not weeks, because someone built a solution rather than waiting for permission, because someone else recognized value rather than protocol violation, because an organization facing crisis chose adaptation over procedure. That choice, more than the device itself, changed the course of the Normandy campaign and demonstrated principles that remain relevant wherever humans fight. The story ends where it began, with a sergeant, a welder, and an idea that nobody wanted to hear until desperation made them listen. 6 weeks of bloody stalemate, 6 days of breakthrough, 60% of an army's tanks modified with unauthorized equipment, one improvised device that helped win a battle, save lives, and prove that sometimes the best solutions come from the least expected places, built by the least credentialed people, tested under the worst possible circumstances. The hedgerow cutters didn't win World War II, but they broke the bocage, and breaking the bocage broke the German defence of France. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.